Let's go through the same process again for the second example here. We'll find that although it looks rather similar in many respects, this minus sign has a huge impact as to what the curve will ultimately look like. Alright, so first of all, let's try and establish any values of x that we can't have. Now, to do that, it's often, if it's possible, very useful to factorize the expression in the denominator. And this is a difference of two squares, and a difference of two squares will factorize like this, x plus 1 and x minus 1. And because we're not allowed 0 in the denominator, definitely x does not equal minus 1 or 1. Because if I have minus 1 here, this whole expression in the denominator would be 0. And if I had x as 1 here, this whole expression in the denominator would be 0. So x does not equal minus 1 or 1. They're going to be asymptotes. They're going to be vertical asymptotes for this curve at these two locations. Alright, now we'll check for the intercepts. If we look for these intercepts, again we'll try for the x-intercept first, which means y has to equal 0. And when we put that into the expression we've been given, the equation, the function that we've been given, 0 equals 1 on x squared minus 1. Well, there just is no value of x that will ever make this expression here able to be equal to 0. In order for that to happen, we would have to have had an x factor up in the numerator of our expression, but we don't have one. So there's no value of x that will make this equal to 0. So there are no x-intercepts. The x-axis will be an asymptote of some sort. So let's try what happens with the y-intercept. The y-intercept, that means x is equal to 0. And if we do that, that means y will equal 1 over minus 1. So there will be a y-intercept at the value where y is equal to minus 1. So we'll just put those coordinates for that intercept here. X is 0 and y is minus 1. Alright, now again actually, if we have a look at this, for this curve, we want to know what happens as it goes way out to positive infinity or way out to negative infinity. So we're going to have a look at those limits. The limits as x approaches positive infinity of 1 over x squared minus 1. So what we're going to have is here we'll have a very large number, minus 1. But a very large number squared, minus 1, is going to make this overall expression approach 0 as its value. So it will be approaching, the limit of this will be 0, which means, as I said before, that we're going to end up having x as an asymptote for this curve. Alright, because 1 over a large number squared approaches 0, and as this large number has no bounds, it's getting very, very large, and squared, that means this will become exceptionally small, infinitesimally small, so it's approaching 0. That's what its limit is. And likewise, the same thing will happen for the limit as x approaches minus infinity of this same expression. It will also end up equaling 0. So if we have a crack at drawing a little bit of a sketch on this one, right, we have our axes. There's the x-axis, there's the y-axis. What did we say? It crosses the y-axis at this point when x is 0 minus 1. So it crosses at the point 0 minus 1. So let's put that important piece of information there. That's an intercept, the y-intercept. And now as we have larger and larger values, what we'll find is that this is approaching 1 it's approaching 0 as x gets larger and larger. But what we haven't done as yet is we haven't actually indicated that we've got these two asymptotes. So x is not allowed to equal -1 or 1. So let's put those two asymptotes in. Can't equal -1 and it can't equal 1. Okay, so here are asymptotes, -1, x equals 1. Now what we want to try and do is figure out, well, what happens in these different regions of the number plane that we've been given. We've got a region of the number plane that's over here to the left. We've actually kind of got a couple of regions here. We're not sure what's going to happen there. And then we've got this region off to the right. So let's take a look at these little bit by little bit. If I just take an example of, say, a point somewhere in this region. We'll call this region 1. So that's the first, this will be the second, this will be the third region, and this will be the fourth region. Alright, as I look at these regions, then in the first region, let's take a value of x down here, which is definitely less than -1. So and a nice easy one would be maybe -10. If I put x equals -10 into this, I'll have 1 over -10 squared, which is 100 minus 1, which is going to be 1 over 99, but it's a positive number. It's definitely a positive number. So what's going to happen is this will be above the x-axis. Now, as I get closer and closer and closer to 1, this here will end up being closer and closer and closer to 1 minus 1. The difference between these two expressions, this bit, the x squared and the -1, the difference between 1 and x squared will become smaller and smaller and smaller. But if I have 1 over something that is very small, then that's a big number. 1 divided by a very, very small fraction gives me a big number. So as I approach this asymptote, I'm actually going to end up having, as the closer I get to this asymptote, I'm going to have a huge value for the function as I get closer to that asymptote. Let's go over to the fourth region, see what happens there. It's a very similar thing. If I'm approaching this asymptote, I'm approaching the value of x equals 1 from this side. Alright, so it'll be 1 over, now the difference between these two things here, as x gets closer and closer and closer to 1, the difference between these two things will become smaller and smaller and smaller and smaller. And as it becomes smaller, then 1 divided by a very, very small fraction, like maybe a millionth or a billionth, 1 divided by a billionth is a billion. 1 divided by a trillionth is a trillion. So that means as I get closer and closer to this asymptote from the positive side, my curve's also going to give me extremely large numbers. Now we've got to try and sort out what's going on in these sections here. Okay, well, let's try approaching a value of x, which is going to be coming towards 0, but from the negative side. So it'll be a very small value of x, but it'll be on the negative side. Okay, so if it's a very small value of x, let's say it's a quarter. Okay, minus a quarter. We're on the negative side. So if I take minus a quarter here, well, just thinking about it quickly, minus a quarter squared, if I have minus a quarter and I square it, that's going to give me 1/16, positive 1/16. And so if I've got 1/16 minus 1 here, what I will end up getting is a negative value. It'll be 1 over a negative denominator, because 1/16 minus 1 is going to give me minus 15/16. So it'd be 1 over a negative. So this will end up being negative here. And then, oddly enough, again, as this approaches minus 1, as the value of x approaches minus 1, our asymptote, as we get closer and closer to here, the difference between these two things will get smaller and smaller and smaller and smaller. Same treatment. 1 over a tiny, tiny fraction is going to be a huge number, but in this case, it will be a huge negative number. So what's happening here is the curve goes down like that, and if we follow the same process on the other side of x equals 0, all right, when we're close to here, then this will be a negative number, and as we approach 1, as we approach our asymptote of x equals 1 here from the negative side, so instead of approaching it from the positive side, the larger side, we're approaching it from the smaller side. As we get there, then the difference between these two things is going to get smaller and smaller and smaller, and you will find, following the same process, that the curve is going to look like this. So it'll be an upside down U shape. It's not a parabola. A parabola actually gets wider and wider and wider and has no ceasing to its width. But this one is not a parabola. This one is actually just an upside down U shape, and it's bounded by the lines x equals minus 1 and x equals 1.